including saying that the log started at the top, so it works. So any questions about how that works?
We go back to STATA.
Sure. Okay. So there are many more exercises in the worksheet, but I just wanted to give you sort of verbal entry and introduction to it. So the last thing we're going to do today is to talk about histograms, the most basic of graphical representations. So let's load up the 2002 data set, which have already been saved. So just use NAT 2002. So let's just do the simplest kind of histogram with no options changed. So the command is histogram, as you would expect for a histogram. What I need to point out to you first, however, is that STATA has almost unlimited graphing options: line graphs, hazard plots, survival plots, bar graphs, my favorite, pie charts, and everything else. So histogram is unique in that it doesn't start with graph. And let me just point out to you before we move on that if you want to go home and sort of create graphs of your own, typing help graph will give you the entry point to all the other kinds of graphs you can create. And the command syntax is very similar to what we're doing now with histograms. So with with histogram, it's like every other command. Command is histogram. What are we making a histogram of? The age of the mothers. Histogram, only variable we have, age mom. Hit return. Let's see what we have. So there are several things to point out to you here. One is, what's up with that? We're just totally missing, it looks like, observations of what looked to be about 23 years old and 33 years old. That is a relic of the fact that STATA tried to guess what the proper bin width would be. Each of these is a bin, and its width was specified in STATA. I think it's like 0.18 or something like that. So that's why there are these gaps here. There's actually no missing data. And the way we would come back to verify that is to go back to STATA and to use the tab command for age of mom. And as you see here, there are definitely people at 23 years of age, and even around that, it's a continuous variable as you would expect with age and whole years. There's nothing missing, so what's up with that? Doesn't really make much sense, but you can be satisfied that the histogram command worked correctly because this is your favorite friend, the normal distribution, and it works here. You see the 12-year-old here, the 54-year-old here, and most people are giving birth within this sort of range between 24 and 54. So this is normal distribution. It sort of makes sense intuitively to you, I hope. And what we need to do now is sort of think about different and more effective ways to represent the data here using the histogram function. And I start with histogram because all of the principles here apply to all the other graphing options on STATA. So the first thing to do is to try to figure out why, and just hit break if you had used the tabulate command. First thing to do is figure out why it looks so strange. And the way to do that is to use the options, graph again. So histogram, age mom. But this time we have two things we can do. We can either specify the total number of bins we want to see, or we can specify the width of those bins. And so let's just be very precise. Let's try out histogram age mom, and let's specify the bin width as 1. So the bin width 1 means that for every point, for every age category, there's going to be 1 bar. So let's see what that looks like.
Why wouldn't it assume that anyway?
It tries to fit it best using some very complex, I think it uses a limit function. Sort of squeeze them down using the Riemann formula. Sort of squeeze down and try to guess, and sometimes it's just wrong. So it doesn't really know what distribution you're sort of looking for first. So this is why it's useful to know how to specify it. STATA is probably better than any of the other statistical programs that I've seen because of its incredibly detailed graphing options, which drives me insane sometimes, but which is also great. Otherwise, I typically do sort of post hoc changes on SPSS or other things. So I like STATA because you have a ton of control from the beginning using this sort of command code. So let's see what this looks like when you've reduced the width of each bin to 1. I think it looks a lot better. There's no missing things. This graph pretty much looks the same. And everything else is that. Do we have any questions about how we did the histograms?
Can you make that continuous if you want?
Sure. Let's see how far we can squeeze it down. So what Lori's asking me is, can we squeeze the bin width down so it looks smooth coming across? I don't know. Let's see if this works. I don't know if there's an upper bottom limit. I've never tried this. Oh, I suppose it's so thin I can't see it anymore.
I was actually thinking, could you impose a curve to...
Yes, you can absolutely impose a curve.
Am I driving people quite crazy with
No.
that question?
So this is a great question, because let me just show you first that there are other options simply, and then I don't actually remember how to do the curve offhand, so I'll do it just afterwards. So the one thing you can do is to sort of think about a normal distribution as having points, as you know, that should fall between 1 standard deviation and 2 standard deviations. There are ways to sort of look at these key points. And the way to do that is with the X-line option. The X-line option, as you may or may not guess, draws a straight vertical line through the X-axis at any point you choose. So the X-line option, for instance, let's say we're interested in the points at 25 years of age and 35 years of age. You can draw as many X-lines as you want. And they can be specified with the width option. So understand that after the comma, you're not really limited to one or two. You're not really limited to just one or two options. You can put a whole plethora of options, which is why I said STATA was so customizable. So let's see what this would look like. So what this looks like is, as you see at the crossing the x-axis at, about 25. You have this one line, and we can actually overlay the line. But I just wanted to make it a very simple command first. And 35, so you can overlay that line this way. So we can see that most of our observations sort of fall between there. I'm a little bit skewed. I should be moving back left a little bit. So the last thing today is to bring absolutely everything we've learned together into one big graphic data file. What we're going to do is to use local variables, R-class variables, to bring it all together and to see how standard deviation lines fit with this histogram. So we're going to create another do file. So let's repeat the process. Open Notepad, file save as. In all files, we're going to call this master. I'm just going to call it master graph. You can call it whatever you want. .do. Save as type all files. Make sure that's checked. Hit save. So just type whatever you want to describe what this would look like. That would be the best graph ever. So what we want to do now is to check at what points on the distribution we're going to want to see, say, 1 standard deviation below and 1 standard deviation above the mean. So the first thing we do, as with any data set, is to clear. And then we're going to pick the data file we want, which in this case is the 1968 file. Just to be safe, I'm going to use the insheet command. And then we're going to calculate, or we're going to let STATA calculate the values for the standard deviations here. So the way we're going to do that, we know what the variable is. It's the age of the mother. Yes, Christine.
Convert it to DTA, or have you already done that, so it doesn't matter?
That's a good question. So I'm not assuming that it's already been converted, but for the purposes of this data set, basically when you use the insheet command, STATA automatically converts it just for the sake of that session until you tell it automatically to save.
Okay.
So anytime you use insheet in a do file like this, it's converted for the purposes of this file to a .dta file STATA can use. So summarize the age of the mom, and then as you remember, there are R-class variables that show up. One of the R-class variables that shows up is the R standard deviation variable. Let me just show that to you.